Hi everyone, welcome back to Transmath 2. We're going to skip ahead to lesson 4 today. We're going to talk about multiplying fractions the traditional way. So the way we were doing this the other day was with those rods, and we were kind of using those as like an area model to show how we could multiply fractions. So there's another way to do it. This is the traditional way, and we're going to go ahead and dive in. What is multiplying across? We've already learned how to multiply fractions by using fraction bars and area models. There is a shortcut that's actually easier. We can multiply the numerator by the numerator and the denominator by the denominator to get the answer. Let's try it with this problem. Rewrite the problem as 2 times 1 over 3 times 2. First, we'll multiply 2 times 1, and then that equals 2. Then we'll multiply the denominators 3 times 2, which equals 6. We can check our answer by using an area model. Notice we have 1 shaded out of 2 parts to represent 1/2. Then we have cross-hatched 2 out of the 3 parts that represent 2/3. We have 2 overlapping parts. So 2 is the numerator. And we have 6 total parts. So 6 is our denominator. This area model confirms that the answer is 2/6. Let's look at another example. For the problem 1/3 times 1/4, we multiply the numerator by the numerator, or 1 times 1, and the denominator by the denominator, which would be 3 times 4. The answer is 1/12. We can confirm this by looking at an area model. We shade 1 out of 4 parts to represent 1/4, and we crosshatch 1 out of 3 parts to represent 1/3. One overlapping part, which is right here, and 12 total parts. The answer 1/12 is correct. When we multiply by a whole number, the area model is not easy to use to check your answer. We need to convert the whole number to a fraction and multiply across. Remember, the unwritten denominator of every whole number is 1. We substitute the whole number with the fraction. Now we can multiply as we did before. Multiply across the numerators and the denominators. The answer is 14/5. I find that this way is a little bit easier. You just have to know your multiplication. You can always use your calculator for this, though. Now I'm going to move on to the second part of our lesson today. Alrighty, so the second part of our lesson, the problem-solving portion, is we're going to talk about angles and what angles are and different parts in angles. This is an angle. Angles make use of what we have learned about points and rays. An angle is made of 2 rays that come together at a single point. In this ray, that point is labeled point A. This point is also called the vertex of the angle. When we name an angle, we use the name of the vertex. The vertex of this angle is point A, so one name for this angle can be angle A. Sometimes there's a point labeled on each of the rays. In this case, we can name the angle by using all 3 points. We could name this angle starting with point B. Another name for this angle is angle B. A, C. The name of the vertex is always the middle letter of the angled name. The other two names can be either at the end of the name. What is another name for this angle? Another name for this angle is angle CAB. This is a protractor. A protractor is used to accurately draw and measure angles. The measure of an angle indicates the size of the angle. Angles are measured in units called degrees. The small circle symbol means degrees right here at the side of these numbers. There are two different scales on most protractors, which can make measuring and drawing angles kind of confusing. Right now, we will use this informal protractor with only one scale so that we can focus on the benchmark angles: 0, 45 degrees, 90 degrees, 135 degrees, and 180 degrees. Let's use the informal protractor to draw and measure some angles. We'll first draw an angle that measures 45 degrees and has rays that are 6 centimeters long. First, draw a horizontal ray that is 6 centimeters long. The end point of the ray, which is this line, coincides with the center bottom mark on the protractor, right here. Then, we draw another ray that is 6 centimeters long and passes through the 45-degree mark on the protractor. This is an exact measurement because the ray passes through a named mark on the protractor. Let's draw another angle. This time we'll measure 100 degrees and the rays will be 5 centimeters long. We'll begin again by drawing the horizontal ray that is 5 centimeters long with the end point at the center bottom mark on the protractor. So from right here through the 0. Because there is no 100 degrees mark on this protractor, we're going to use number sense to estimate the other ray's position. Where should the second ray be drawn? The other ray should pass between 90 degrees and 135 degrees on the protractor, but should be closer to 90 degrees. This angle measure is an estimate. Finally, let's use the protractor to measure an angle. First, we'll lay the protractor on the angle so that the vertex lines up with the bottom center mark on the protractor. The bottom of the protractor needs to line up with one of the rays, like this. Now we'll read the measurement on the protractor that the other ray passes through. So you want the vertex of the angle to fall right in the middle at the bottom part, kind of where we were starting when we were drawing our angles. After we get that right in the same spot, we can see that this angle has a measurement of 135 degrees. We'll do more practice with this in person with real protractors, but I just wanted to introduce this to you guys so that you could work on the assignment and understand angles. So make sure you turn into Schoology to complete your homework assignment for lesson 4. Bye, guys.